So question 2 and 6. So that's chapter 4, question 2. All right. Okay, so have you seen a problem like question 2? In the lectures? Anyone? Can anyone do question 2 for me? Just give it a try. Or have you seen a problem like this? What do you think? No, exactly. You can always practice that. You can always go back to the resource or the book, because that's quite easy, but we didn't really cover that. Okay, and as I said, due to the time duration I had, the limitations of that, I couldn't cover everything. On occasions, I didn't cover some topics intentionally. As I said, I need to take care of the time, and obviously I need you to understand the topics. I just don't want to go over the topics even though you don't understand. Okay, so I think, okay, let me see. It's already 5 p.m. tonight, in the afternoon, of course, and the exam is tomorrow. Okay, let me give it a try, because I'm not sure I'll be able to do that, because there are lots of questions, and obviously I need to go back to all the lectures, because I've been teaching. I'm not really I don't really remember each and every topic I've shown, so it will take some time. I'll try. Okay, I'll try and see if I can do that for you. But I think you should be able to. I think you should be able to differentiate by just eyeballing, because as long as I can see the problem, I can see that I haven't really shown, or rather discussed this topic. Just any questions that don't have the most relevance to the test. Well, again, everything has relevance. As you can see, even it has relevance from Math 95 or Math 96. So the question of relevance is actually out of my hand. What I'll do, if I have enough time tonight, I'll try to send you an email with problems you don't need to do. Is question 2 relevant from chapter 4? We haven't really seen anything like that, so there is no way you will see a question like this in the test. You haven't seen a question like this even in the homework. So anything what you haven't seen in the previous quizzes, in the previous tests, in the homeworks, you don't need to worry about that. Well, if it had relevance, I would have definitely showed a problem like that. Okay, that's one thing you can what should I say? You can ignore. Yeah. Okay, next is chapter 4, problem 6. Okay. Oh, 6 is again with degree 4. So you'll not be asked to do problems like that for the test. But again, I can tell you the idea. Okay, the idea is you just need to check the factors of the what should I say, the constant term, which is positive 12 here. Okay, so the factors of 12 are 1, 2, 3, 4, 6, and 12, right? So you need to check, obviously, plus minus this. You need to check plugging in different factors from this list and see which gives you a 0 in return. Obviously, I'm talking about this. You have to get a 0 instead. All right, what's next? Oops, it says my internet connection is unstable. So by chance, if um, my meeting gets disconnected, stay online, okay? Because I've got a warning that my internet is unstable. I hope it doesn't disconnect me completely. Okay. Okay, number 12. Number 10, sorry. Okay. So use the graph shown to find the following: the domain and the range, the intercepts, the horizontal asymptotes, vertical asymptotes, oblique asymptotes. Yeah, that's a very good question. You might see a question like this tomorrow, right? You might see a problem like this tomorrow. As you can see, you have 5 different birds, and the question is not really difficult. As you can see, it's moderate. You can actually eyeball it. You can actually eyeball everything from this graph, okay? So for the domain, as you can see, you don't have a defined value at a certain point, right? Can you see that? You can see there is a vertical asymptote. As far as I can see, it's at -2 and +2, right? You have a vertical asymptote in red color, if you're wondering, and your graph is not really going past that. And everywhere else you have a defined value, right? You have a value of x and you have a corresponding value of y apart from those 2 points in terms of x, of course. So obviously your domain will be x not equal to -2 and 2, right? All right. Next question is the range of the function. Okay, so let's see. Again, it looks like it's definitely going to positive infinity and negative infinity, but in between we need to check whether it has any other restrictions or not, right? All right, so we can see we have a horizontal asymptote. Let me try to see where is that. First of all, let me draw this. I can see it looks like the horizontal asymptote is at y equals -2, is it? I think so, yeah. It looks like at y equals -2. So I can see at y equals -2, I don't have a defined value. Whichever side you are approaching from, whether you are approaching from the left or from the right, I can't see any defined value for y for 2, right? I don't see anything at y equals -2, not 2, my bad, it's -2. I can't see any defined value for y at -2, right? So definitely -2 is out of our range. It's not a part of our range, okay? Is there anything else? So, excuse me. So I can see from -2, it's going to negative infinity. No problems with that. So that means from negative infinity to negative 2. Obviously, negative 2 is not included. I can definitely eyeball that. Next, I can see it's also going, I have more than one interval, so I'm using this union sign. I'm not sure, I need to see the question, whether it wants me to write using the interval sign or the set notation or the, uh, what should I say? Um, anyway, the algebraic one. Anyway, so it could be either set notation or the interval sign, I guess. Anyway, so it's definitely going to infinity, that's for sure. But where does it start from? So looks to me it's starting from, okay, it's not precise, but it looks like, yeah, I think if I zoom in, I can see it starts from 1 and it actually goes through that point 1. So instead, I want to use this. It will go from 1 to infinity. Okay. Now let me go to the question and see. Okay, so it has the set notation, not the interval. Oh, negative or negative 1, right? Yeah, obviously, yeah. So using the set notation, it should be y less than negative 2. As you can see, it's going towards the negative infinity, and it's starting from 1 and going to positive infinity. So it's greater or equal negative 1. Okay, it's starting from negative 1, including that. So that's why it's a greater or equal. So that should be your answer. Oops, sorry. Right? Okay, next. Find the x-intercept. Okay. So again, I can eyeball it. So to me, looks like the x-intercept is somewhere between 1 and 2, because definitely there is a vertical asymptote at 2. And same goes for the other intercept as well. It looks like it's somewhere between negative 1 and 2. Negative 1 and negative 2, right? Okay, first of all, if you zoom in, oops, sorry. If you zoom in, let me show it. Sorry, I can't really show it to you because I'm sharing the screen on my iPad. So if you can zoom in by yourself, what was the problem number again? Number. Oh, when I tried to zoom in, it actually became too big and took me to some other problem. Number 10. Okay. Oh, okay. Yeah, got it. So if you try to zoom in, let me see. What can I see from that? Okay. So yeah, it looks to me, it goes through very close to the midway, the midpoint of negative 1 and 2 and positive 1 and 2. Okay. Negative 1 and negative 2 rather. So yeah, I think you can take 1.5 and 1.5. I think you can take that. But yeah, again, as I have zoomed in too much, I can actually see it's not quite going through the midpoint. It's actually just before that. That's why probably they have taken 1.4. But yeah, if you zoom in, you can actually see that it's not exactly going through the midpoint. Well, that's a question. Again, that should be good, because it's kind of approximating. But yeah, I think the graph will be you should be able to zoom in. It shouldn't be like this, because that's a PDF you can clearly understand. You can't really zoom that graph separately, but in your problem, I think you should be able to zoom in, or it should be more precise. I'm not sure whether they'll take 1.4 or not. That's what I can't guarantee you, okay? Because the publisher has their own tolerance level. But yeah, again, if you zoom in, I can clearly see it's just before that midpoint. So my intuition would have been also 1.4 and negative 1.4. Okay. All right. The vertical asymptote is there. We have already calculated it. It's negative 2. The vertical asymptote is negative 2 and 2, and the horizontal asymptote is at negative 2, and obviously there is no oblique asymptote, right? We can see that. We can just eyeball it. All right, what's next? We still have time for at least one more problem, I guess. 19, okay, 19. Okay, follow the steps for graphing a rational function to graph the function. Okay, so I think I have shown you a problem like this yesterday. Yeah, if you remember, if you go back to the problem, or if you can see the video, I have shared the video with you. I did show a problem like this, exactly like this. Okay, the function is different, but the idea is the same. So yeah, I think we can do problem 12 then. Okay, so problem 12. What is that? 16, 12. Okay. And we probably don't have to do 17. Okay, let me check that first. No, I don't need to do problem 17. Yeah. Okay, so 12. So it's 2 over x minus 9 greater than 4 over 7x minus 3. Okay, what should we do? What's the first thing comes into your mind when you see a problem like this? I'll take answers from you first, because that's quite an easy problem. You have done this in Math 95, but still you need to have the basic idea. Otherwise, you might go in the wrong direction. Obviously, we'll have to solve it. So we are trying to isolate x, but how can you do that? Yeah, I know we are going to isolate x because we are trying to solve it. But how can you isolate x? What's the first thing we need to do? Or what's the first thing you could do? You could do several things. Multiply 7x minus 3 on both sides. How would that help? Because I'll still have a fraction on my left. Get it on the same side. Yeah, that's what we can do as well. Okay, as I said, we can do several things. We can change sides for this. We can go for the common denominator, and then we can simplify it. But the thing I'll do is I'll cross multiply. Yeah, Daniel, very good. I'll actually cross multiply because excuse me, this will help me to get rid of the fractions, and that's more convenient. Okay, so it will be 2 times 7x minus 3 greater than 4 times x minus 9. Okay, and if I distribute it, it will be 14x minus 6. Oh, sorry, 4x minus 36. Now I'll change sides for this. Okay, I'll take it here and bring that here. So it will be 14x minus 4x, which will be greater than negative 36 plus 6, right? If you change sides, the sign in front of it gets altered, right? So it will be 10x, oops, 10x greater than negative 36, and if I solve it, I'll get x greater than negative 36 over 10, or I could write, if I divide it by 2, it will be 18 over 5. 18 over 5. Oh, sorry. Yeah, my bad. Yeah, thank you. I need to add 6, right? Sorry. It will be 30. So this will be 30. Oh, this will be 3. Yeah, very good. It's actually even a better answer. Yeah. So it will be greater than, oops, sorry. It will be greater than negative 3. That's for sure. But is this the answer? And the answer is no, because if you remember, we started with a fraction. So there are certain values which we need to take care. We need to take care of the denominators. That's the next thing you need to check. Or you can actually calculate it first and then the other thing, okay? Either way will do, you'll get the same result. So if your denominator for the first expression is not 0, that means your x can't be 9, okay? And for the second one, if your denominator is not 0, 7x equals 3, x equals 3/7, okay? So your x can't be 9, it can't be 3 over 7 either, but it has to be greater than negative 3. That means it will start from negative 3, it will go up to 3 over 7, it will stop there because we can't really include that. Then we'll start from 3 over 7. Okay, oops, sorry. We'll go to 9 and from 9 to infinity. Okay, any question from this? Because your x has to be precisely greater than negative 3. Okay, any value greater than negative 3 will be allowed apart from 9, because that's making your that's making your first denominator 0, and you can't take negative 3/7 either, because that's making your second denominator 0. Now let me check one more thing. This needs to be strictly greater than, right? Okay, so okay, one more thing to check. Oh, we need to check. We have 3 intervals. We need to check whether it actually keeps my inequality right or not. Okay, I'm actually going there, yeah. The answer is from -3 to 3.7, sorry. The answer is basically these two, this one and this one. So if you have intervals like this, you need to write all of this. The only thing you need to take care here is whether this interval, all of these obviously, you need to check whether this interval is keeping your inequality intact or not. If it does, then you need to write like this. It doesn't mean that it's the middle part you can avoid it. No, it doesn't work like that. The only thing you'll see in this interval, your inequality doesn't really hold. So if you take any value from 3.7 to 9, let me show what happens. Oops, sorry. So your problem is 2/x minus 9 and 4/7x minus 3. If you take any value from this interval, can you see what's going on here? So definitely any value within this interval will make this negative, but this will still be positive. So if you take any value from this interval, this will happen, which is not true, because we are trying to solve it for the values of x for which the reverse direction is true. That means this is true. But if you take any value from this interval, take any value, let's take 4. 4 is from this interval, right? You can see 4 minus 9, it's a negative value, whereas this will be positive because it will be 27 minus 3, which is 25. That means this inequality won't hold. So even though we had 3 intervals, we need to check whether the inequality holds for all of this or not. Fortunately, you'll see these two will hold, this won't. So your answer will be these two, okay? You don't need to know intermediate value theorem, okay? You'll see that in Math 181. That's why I have avoided it. Okay, so that's it. Tomorrow you'll have your exam. So best of luck for that.